Welcome to the African Origin of series, a series where we speak about the African origin of various items and the way they contributed to humanity's progress. This series aims to re-establish Africa's position as a central part of world history. In this episode of the African Origin of, we take a look at the African origin of mathematics. When one takes a look at the Wikipedia page on the history of mathematics, one realizes that Africa is barely mentioned. It is only Kemet, ancient Egypt, which is mentioned, and even there the role of Africa is downplayed. Instead, what one sees prominently mentioned there is Mesopotamia, Greece, Babylon, and medieval Arabs. Africa's crucial involvement is completely left out. This shouldn't be surprising though, since the trend in world history is to exclude Africa wherever it can. But no more. We are here to set the record straight.
I've come to set the record straight.
Africa is not only the birthplace of mathematics, but it is also the place where it became the complex subject we know today that so many students love or hate. Keep watching this video if you want to see the evidence I will present here to back the statements I have just made. Your mind will be blown away, I'm sure. So how do we know that Africa is the birthplace of mathematics? Well, first, that is because Homo sapiens were born in Africa and they were anatomically modern humans. So we can assume that by at least the 100,000 years they spent on the continent before leaving, that they must have had the ability to at least count, add, subtract, divide. And we have evidence for this. You hunt, you gather. How do you divide the booty fairly among your peers? You count and you divide. But this abstract, quite commonsensical evidence is not the only evidence I have to present for Africa being the birthplace of mathematics. For that, we have something somewhat more tangible. We have archaeological evidence. The first and oldest archaeological artifact found to support an African origin to mathematics is from the Blombos cave in South Africa. In this cave was found rock art and ostrich eggshells that contain clear geometrical shapes, rectangles, triangles, diamonds, etc., as you can see on the screen. And for those who might have forgotten their math lessons, geometry is part of mathematics. These rocks and eggshells were dated to around 70,000 to 100,000 years ago. Let that sink in. This is the earliest evidence in the entire world of such drawings, by the way. And as you will see further in our series, this Blombos cave is also the place where one can find the earliest evidence for other interesting human activities. Stay tuned if you want to know about those activities. Now, this doesn't mean that humans were first able to do geometry before addition, subtraction, and such. This just means that the earliest archaeological evidence of mathematics we have is that of geometry. Now, some people might be skeptical and say that these drawings don't constitute evidence for geometry, but I beg to differ, and so do many other scholars. These drawings clearly showcase that our early ancestors from Africa understood shapes and how they were formed. This means they understood points, lines, and how to put them together to form certain shapes. This is basic geometry. So that's right, before anyone else, Africans were already using basic geometry. This basic geometry invented by Africans 70,000 years ago is still in use today in modern technology. For example, the triangular patterns on this small piece of rock art you see on the screen right now found in the Blombos cave are the same patterns used in triangulation technology in GPS and geolocation apps today. That's right. This technique exists because our ancestors in Africa started drawing and studying shapes. That's quite the contribution right there. The second archaeological artifact we have is also from South Africa, dated at around 40,000 years ago, the Lebombo bone. This artifact, as you can see on the screen, has clear incisions on it. These incisions are also clearly made on purpose by a human. Therefore, this led some experts to suggest that these incisions were made for some mathematical purpose, most likely to count items or days in order to devise a calendar, or perhaps to count a menstruation cycle because of the number of incisions found on the bone, which would suggest that the first mathematicians of this planet were African women. I like this menstruation cycle hypothesis better, and here is why. I think it makes more sense that women were the ones who devised such a tool to count days for so many reasons. One is that they had time to do that as the men were busy hunting. Two, they had more reasons to do so because their menstrual cycle, which they must have noticed by then, was a recurring thing, so counting days until that happened again makes a ton of sense. One thing is sure, these incisions on the Lebombo bone are not random at all, and they clearly suggest mathematical knowledge. Now, this next artifact is an even more impressive artifact of earliest mathematical evidence in Africa. Found in the DR Congo this time, we have the Ishango bone, dated at around 20,000 to 25,000 BC. This artifact was found by a Belgian explorer in the Ishango region in Congo. This is in the eastern region of Congo in the Great Lakes region. This artifact is, by most scholars' admission, a mathematical tool, and it seems to suggest that the people of Ishango had a complex understanding of mathematics. You will soon understand why the scholars believe this. As you can see on the screen, the Ishango bone has got a bunch of markings on it. While some might say that those markings are just random grape markings. However, this is quickly debunked when one takes a close look at those markings. So let's quickly do that too, shall we? As you can see on this breakdown of the markings, the bone is covered on each side by a very specific number of marks, which are obviously not random. We have 48 marks on one side, that's the middle side there, and 60 on each of the other two sides. Clearly, the person who made those markings wanted those numbers there, otherwise those numbers would have been inconsistent, but they are not. But that's not all about this bone, there's more. Those large groups of marks are also divided into smaller groupings containing each a specific number of marks. What is even more perplexing for scholars is this. The series of numbers in some of the small groupings of markings clearly demonstrates that the Ishango people were acquainted with prime numbers between 1 and 20. If that doesn't impress you, maybe you should Google the concept of prime numbers. This alone shows that they had a complex understanding of mathematics. Another thing that demonstrates that the Ishango bone is clearly a mathematical tool is its ability to perform additions of a certain level of complexity. And for that, I will let the Professor Niousere Kalala Omotunde give you an illustration of it. Enjoy!
J'ai amené un certain nombre de choses et c'est important de pouvoir apprécier ce qui a été fait. On est parti.
L'os d'Ishango est un artefact neuronal, alors prenons le temps d'apprécier les symétries de calcul. Nous le savons, 11, c'est 10 plus 1. En bas, 9, c'est 10 moins 1. Mais 21, c'est 20 plus 1. Tandis que 19, c'est 20 moins 1. De l'autre côté, 11, c'est 15 moins 4. Tandis que 19, c'est 15 plus 4. 13, c'est 15 moins 2. Tandis que 17, c'est 15 plus 2. Nous voyons bien ici la cohérence des symétries de calcul. Continuons. 11 plus 13 égale 24. Tandis que 11 plus 21 égale 32. Alors comment passe-t-on de 24 à 32 en rajoutant 8 ? 17 plus 19 égale 36. 19 plus 9 égale 28. Comment passe-t-on de 36 à 28 ? Eh bien, tout simplement en retranchant 8.
Quite fascinating. I was saddened to hear that this great African genius just left this world. But his word lives on with us. His message is still here. He left books, lectures, conferences, and many videos, as he was a strong believer in spreading knowledge to as many people as possible. So please, I encourage you all to go watch his videos. I don't care if you don't understand French, just turn on the subtitles. They are translated for you by YouTube. You will enjoy. Just please do that. You will learn a lot from this great man. Rest in peace in the land of ancestors, Niousere. The professor also says that there are other studies that have come out that suggest that even more complex mathematical operations could be performed with the Ishango bone. It seems the more they study the bone, the more it reveals its wonders. And this is a 22,000-year-old artifact. Just amazing. The only sad thing with this artifact is that it is not in its country of origin. If you want to take a look at it, you have to go to Belgium, and you will find it in some museum over there. And they have also made a huge replica of it in one of their cities, which shows you that this artifact is indeed something significant in the history of mathematics. The Belgians are adamant about it, and I am too. But one other sad fact is that many Congolese people themselves ignore the existence of this great artifact, and I think that is a shame, a great shame. When I go home, I intend to rectify that. So, all three of the world's earliest evidence of mathematics are found in Africa. This nails the coffin on this question. Mathematics was definitely born in Africa. Africans were the first to practice mathematics. They were the first to initiate the practice. Now, is this where the video ends? Some people will say, sure, Africans were the first to do mathematics, but it was just basic additions and divisions, that's all. Eurasia, on the other hand, is responsible for complex mathematical knowledge, such as algebra, geometry, trigonometry, and so forth. What do you say to that? Well, you're wrong there too. Westerners tend to put an emphasis on the ancient Greeks for the discovery of complex mathematical formulas and so forth, but the reality is completely different. Complex mathematics were already in use in Africa for thousands of years before the Greeks were even a civilization. In the Nile Valley, for example, evidence for complex mathematics is clear there for all to see, in Kemet and in Taseti. But this is not what you hear in world history narratives. There you will only hear Africa's involvement being pushed down in favor of other places. For instance, this Wikipedia article says that both the Mesopotamians and the Kemites started practicing mathematics at the same time, but this version is not accurate. We already saw that somewhat complex mathematics were already in use in Africa in the Great Lakes region at about 17,000 years before that time. And since the people of the Nile Valley are direct descendants of people from the Great Lakes, it only stands to reason that over time their knowledge of mathematics deepened further during their slow migration towards the Nile Valley. And this statement is supported by Kemet's clear superior knowledge of mathematics over any other ancient civilization. And there is evidence to substantiate that the Nile Valley people had older, superior, and deeper knowledge of mathematics. Such evidence is 1. Naphtha Playa. This earliest astronomical site in the world displays complex astronomical knowledge which can only be achieved with complex understanding of mathematics, as all scholars agree. 2. The calendars of the Kemites and the Kushites. The people of the Nile Valley devised the most accurate calendar of the ancient world and even of the modern world, since we still use the calendar the Greeks and the Romans stole from Kemet and appropriated. All scholars agree that the Mesopotamian calendar was off by several days, while that of the Kemites and the Kushites was most accurate of all, which suggests older superior knowledge of the concepts that can bring about such accurate measurement of time. The use of algebra and geometry in Kemet and Kush was far superior to that of Mesopotamia. This is not even a question of debate. Most scholars agree to this. but we don't even need their opinion. Just look at their pyramids and other constructions. They stand as testimony of their superior ancient knowledge of geometry, trigonometry, algebra, arithmetics, and mathematics in general, and also the forces of nature, because you can't build such monuments if you don't understand how the forces of nature interact with each other. Coming from a civil engineer here. One cannot build such monuments without a deep and complex understanding of math and physics. 4. The ancient Greek mathematicians went to acquire their deep understanding of mathematics in Kemet. The famous Pythagoras, for example, is known to have learned and studied in Kemet for about 20 years. That's right, Google it. And his famous Pythagoras theorem was already in use in Kemet more than 1,000 years before he was born. Same for Thales' theorem. I believe these theorems need to be renamed. The oldest records of such theorems being used were found on the Rhind papyrus, written by the Kemite scholar Ames. I believe the theorems should be renamed Ames' theorems. In fact, most of the complex mathematical knowledge and astronomical knowledge of the Greeks was learned and acquired from Kemet. The Greek scholars only appropriated that knowledge once they got home. And there is evidence to support this. Ancient Greek historians themselves wrote about this. Yes, that's right. Ancient Greek historians wrote about the fact that most of their brilliant scholars went to study in Egypt. For example, Plato went to study in Egypt too. Anyhow, let's continue. There is much more evidence that Kemet and Kush knew better mathematics. For example, the ancient Kushites and Kemites already knew how to calculate volumes of spheres, cones, cubes, pyramids, cylinders, and so many other shapes. They already knew how to calculate surfaces, circumferences, and all the rest. They already knew this. Their geometrical knowledge was off the charts. Just look at their constructions. It suggests a deep understanding of geometry. You can Google the Rhind papyrus. Name on the screen. The Rhind papyrus, written by the Kemite scholar Ames. It shows Kemet's very complex mathematical knowledge. And also, it is known that the Kushite kingdom was very well acquainted with the concept of the harmonic ratio. It was all over their constructions. The Fibonacci series, that is the golden ratio, was already known in Kemet too. All this evidence supports the idea that Africans of the Nile Valley had an older, deeper, and superior understanding of mathematics, which they inherited from their ancestors coming from the Great Lakes region where the Ishango bone was found. And this deep knowledge of mathematics is found everywhere in Africa today and throughout the ages. For example, Africans have always made use of fractal geometry in their kitenge clothings and braids patterns. Just look at the screen. These are kitenge clothings. They show you typical fractals. And if you don't know anything about fractals, it's a mathematical concept of geometry. Look at these braids, typical fractals, and fractals are found all over nature. How did Africans put it in their designs if they did not understand the concept of fractal geometry before anyone else? And that's just mind-blowing. It shows you that they had already studied nature way before for a long time, and they noticed something, that there was a fractal geometry in nature that could be captured and put in our designs too. We always mimic nature because the divine is in there. Another example of African mathematical tradition is in its divination practices. The YouTube channel From Nothing, Shoutouts From Nothing, made a video on West African divination where he showed how they are a mathematical algorithm that follows a binary system. The divination of the West African people is a binary system. I'll link the video in the description so that you can go check out the video of From Nothing on this topic. It's a great video. I don't need to make it, just follow him. Speaking of algorithms, did you know that Ethiopian mathematics are the only mathematical method that can run computers? Here is an extract from the BBC on this subject.
Could you imagine a world without fractions? A world where you could throw away your times tables? Well, there has been such a world here in Ethiopia, where for thousands of years, merchants used a strange yet very sophisticated system of multiplication to calculate the price of goods at markets throughout the Horn of Africa and the Middle East. Today, the price of Ethiopian coffee is calculated on cash registers. But where we in the West rely on modern technology, thousands of years ago, traders made their calculations with pebbles. All they needed to know is how to halve a number and how to double it. To Western eyes, the Ethiopian system is so strange that it seems more like a magic trick. To multiply 11 by 15, put the numbers into 2 columns. Keep halving the number on the left, ignoring all fractions. 11 becomes 5, becomes 2, until you reach 1. In the other column, you double. 15 becomes 30, becomes 60, becomes 120. Whenever an even number appears in the halving column, ignore the row. Group the remaining beans in the doubling column together and count. You get 165, the perfect answer. It seems unbelievable that a system can ignore fractions, even throw away parts of the calculation and still come up with the right answer. But it works every time. Take another example. When we multiply 31 by 25 using long multiplication, we multiply 31 first by 5 and then by 20, and add the results together. In Ethiopia, instead of multiplying by 5 and 20, they were effectively multiplying by 1, 8 and 16, just a different way to arrive at the number 25. By doubling a number, you're just multiplying by powers of 2. In our right-hand column, the number 31 has been multiplied by 1, then 2, then 4, then 8, and finally 16. But all that we need are the numbers that make up 25, that is the 1, the 8, and the 16. And here's the clever bit. By crossing out the even numbers on the left, you're always left with the correct powers of 2 on the right. In this case, the 2 and the 4 disappear, leaving 1, 8, and 16. By breaking the multiplication into powers of 2, the calculation has been converted into base 2 arithmetic. Once the sum has been broken down, all that remains is a simple addition. It's a system that seems completely foreign to Western eyes, but in fact we use it thousands of times a day because it's this system that powers today's computers.
So there are 3 ways in which this is written. Secondly, it's breaking multiplication down into a series of addition. And thirdly, it's breaking everything down into very simple steps.
Making calculations as simple as possible was all the inventors of the Ethiopian method wanted to do. The solution they came up with is central to the way we live today. The ways they perform their calculations are almost exactly the same as the working methods of a computer. Amazingly, it seems that centuries before the invention of computers, Ethiopian traders cracked the code that lies behind the modern age.
These facts showcase the depth of African mathematics and a deep-seated mathematical tradition in African societies. In fact, many African board games are based on an algorithm. This has been studied by many scholars. The African board game Tsoro from Zimbabwe, for example, is based on an algorithm. This game also goes by the name of Ayo, Bao, Guti, Lela, Mankala, Ore. It depends on the region you're in, basically. Yeah, you can also find this board game on Apple Store under the name of Ore. So yes, there is a deep-seated tradition of mathematics in African societies. It is very obvious to see when scholars chose to look at African traditions in a mathematical way, and what they discovered was mind-blowing to them. They were like, whoa, Africans already knew the binary code, Africans already knew fractals, and turns out the only method of calculation that make computers work is an African method. Why? Because African mathematics and tradition of mathematics was already very acquainted with binary code. And that's just very sophisticated because practiced and passed down from generation to generation for literally tens of thousands of years. With all this evidence, we can safely conclude that Africans clearly practiced complex mathematics first and influenced others in this field of knowledge. Africans initiated the practice of mathematics, developed it, and turned it into the most useful field of knowledge this world has ever known. Also, do you know how the priests of Kemet defined mathematics? Here is their definition. Accurate method of investigation of the knowledge of all existing things and all obscure secrets or mysteries. This definition was found on the Rhind papyrus, written by the Kemite mathematician Ames. And scientists today still agree with this definition. We use mathematics to accurately determine everything in all fields of science, be it psychology, biology, chemistry, and so on. They all rely on mathematics for accuracy and certainty. And Africans were the first ones to initiate this method of investigation. Quite the contribution to humanity, wouldn't you agree? If you do math today or use anything tech related, it is because of that first African contribution of mathematics that paved the road for all this to exist. It is time to stop teaching lies to children about how complex mathematics started in ancient Greece and that anyone before them just used simple mathematics. The ancient Kemites and Kushites knew and used an even older and more complex form of mathematics, which they inherited from their ancestors from the Great Lakes region of Central Africa, which they then imparted to the Greek scholars who are now falsely hailed as the originators of that knowledge. Please teach that in school. It is important to remind African children, African people, and the world in general that Africa has also contributed greatly to the development of humanity and this world. That is all for this episode. Please like, share, comment, and subscribe. Peace. Did you know that an African slave in the Americas was known to be the person with the highest power of mental calculation in the world? His name was Thomas Furler. He was an African who was shipped as a slave in the Americas.